Hello everyone, in this video we will cover section 4.7, which is inverse trigonometric functions. Before we go into that, let me refresh your memory from the past. So recall that a function f of x has an inverse, which is usually denoted by the -1 as exponent, if and only if f is 1 to 1. So 1 to 1, it means that it passes the vertical line test. So for example, you have this function. This is a function because it passes the vertical line test. Okay, so it crosses only once. But this is not a 1 to 1. So to be 1 to 1, it also has to pass the horizontal line test. So therefore, this is not a 1 to 1 function, so therefore it doesn't have a inverse. But if it's not 1 to 1, sometimes it's pretty easy to make it 1 to 1 by just restricting the domain. So for example, if we have the graph just like this, so if we only graph this when x is positive, then this will be 1 to 1 because it passes the vertical line test and it passes the horizontal line test. So therefore, yes, this is an inverse function. We technically have already solved inverse functions multiple times. We just didn't call it inverse functions, but you have. For example, so let me do an illustration of what I mean. So for example, we know the sine of 30 degrees, this is from the special triangles, is equals to 1/2. So therefore, and we have done this already, sine inverse of 1/2, it will be equals to 30 degrees. So this will be the inverse function. Now, the only catch here is the sine can be positive in 2 places and negative in 2 places. Remember, we have this before. All the students take calculus. So therefore, sine is positive in here and here. But in order to be 1 to 1, to pass this test, you can only use one positive and one negative. So therefore, for sine inverse, if it is positive, it's going to be here or here. And if it's negative, it's going to be here, which is exactly what this means. So hence, officially, we say sine inverse is to be the inverse function of sine, and it's written like this. Usually, it's also written arc sine inverse, but this is the most common used notation, but these two things are exactly the same thing. And then this is telling you that the domain is from minus pi over 2 to 2. So therefore, if you do a graph for the sine inverse, the graph would look like this. Remember that the maximum the sine can be is 1 and -1. So now if you only go from minus pi over 2 to pi over 2, let's say this is minus pi over 2. Remember that minus pi over 2 is minus 90 degrees or 270 degrees. This is 90 degrees. And the highest will go is pi over 2. So the graph will look something like this. So that will be the graph of the inverse function. Okay. Again, like I mentioned 2-3 minutes ago, technically you already know how to solve these problems. The only thing you have to be careful is to make sure that if it is positive, it's in the first quadrant, and if it's negative, it will be on the fourth quadrant. So for example, if I ask you to evaluate the following. So we'll say evaluate or simplify. So let's say part A is a sine inverse of 1. So which is the only angle that will give you 1 is 90 degrees. So therefore this will be 90 degrees or pi over 2. Okay, so we can also try, for example, sine inverse of radical 2 over 2. So which is the only angle that gives you radical 2 over 2. And remember, from the special triangles, this was 45 degrees or pi over 4. Also, for example, what is a sine inverse of radical 3 over 2? And this is why I say it was very important to memorize the special triangles. Which is the only angle that will give you this. Remember that was 60 degrees or pi over 3. Now the part you have to be careful is, what about if the number is negative? For example, what about sine inverse of negative 1/2? So the reference angle here, the reference angle is 30 degrees because that's the only one that gives you 1/2. But since this is negative, then this is supposed to be on the 4 quadrant. Remember, all students take calculus, so if it is negative, it has to be here. So since the reference angle is 30 degrees, you can technically say this is minus 30 degrees or minus pi over 6, or minus 30 degrees is 330 degrees or 11 pi over 6. Okay? Either way is fine. So now for sine and tangent is going to be very, very similar. So essentially, you have already done this before, but now we're making it more official. All right, so similarly for cosine, remember you can also write this as y equals to arc sine, arc cosine of x, even though again the most common notation is this. Now remember, for cosine, if we go to all the students take calculus, cosine is positive in here because all of them are positive there, and here, and cosine is negative here and here. So now if it is positive, we're going to pick the first quadrant. If it's negative, we're going to use the second quadrant in order to make it a one-to-one function, and this is how we end up with this. So therefore, if you do the graph for cosine inverse, cosine still goes from minus 1 to 1. That doesn't change. But now this is going to go from 0 to pi. So let's say this is pi, and somewhere here, therefore is pi over 2. So the graph looks like this. It goes down, passes through 0, and it does this. Okay. So again, using the special triangles, let me write the special triangle one more time in case you forgot it. I didn't use it for sine, but I'm going to use it now. So remember, this is 30 degrees and this is 60. This will be 1, 2, radical 3. And then if this is 45, and also make sure you know how to change this to radians. Let's say this is 1 radical 2. And also to know the values for the graph. Okay. So therefore, this is all you need to solve any of these problems, at least for now. So for example, if I ask you what is cosine inverse of 1/2, well, which is the only angle that will give you cosine to be 1/2, it will be 60 degrees. So it will be 60 degrees or pi over 3. Similarly, what is cosine of 0? Well, cosine of 0 is 90 degrees or pi over 2. Why is cosine of 0 90 degrees? Remember, the graph of cosine looks like this, where this is pi over 2, this is 3 pi over 2, and this was 1, negative 1. Okay, so this is what we did last time. In the same way, what is, for example, cosine inverse of 1? Well, that will be 0 degrees. What is cosine inverse of minus 1? Well, the one that gives you minus 1 is pi. So, because here this is pi, and so forth. Okay, what is cosine inverse of minus radical 2 over 2? Since this is negative, now this will be on the second quadrant. The reference angle for this is 45 degrees. So therefore, since this is on the second quadrant, so this is 45, then the angle here has to be 135. So this is either 135 degrees or 3 pi over 4. You should check on that. So you can see it's very, very simple, especially if you have memorized the special triangles, which if you haven't, I highly now recommend you to do this point. All right, so finally, let's look to tangent inverse. So this is very, very similar. There's a big difference here, though. There is no equal sign here, and the reason why there is no equal sign is because, so note, this is very important, note the tangent, for example, of pi over 2 is undefined, or you could say is infinity, and tangent of minus pi over 2 is minus infinity. Why? Because you look to the graph, this is pi over 2, and this is minus pi over 2. Those are the asymptotes, so the graph looks like this, and it actually never touches the graph. So that's the only thing you had to watch out for. So this is the graph of tangent, not tangent inverse. So tangent inverse, the graph is going to look something like this. So have the x and y axis, and this is now going to also have an asymptote here at pi over 2, and an asymptote here. This should be minus pi over 2. This is pi over 2, and the graph will look something like this. It has to pass through 0, so it will look like this. Again, to find all the values, they will come from the special triangle values, which is the one we did right now. The only difference is you have to watch out for this infinity part. Okay, so for example, examples. Let's say that I ask you to simplify what is tangent inverse of 1. Well, the only value that gives you 1 for tangent is 45 degrees. So it will be 45 degrees or pi over 4. If I ask you a tangent inverse of, let's say, 0, this will also be 0 degrees or 0 radians. And let's say I ask you now what is tangent inverse, for example, of radical 3. And let's say you haven't memorized it, you can quickly create a triangle. Let's say this is 30, there will be 60, so it will be radical 3, this will be 2, this will be 1. So if you want tangent to be just radical 3, so tangent has to be this over this. So that means this is 60 degrees. So you can see everything depends on these triangles or pi over 3. Now the one you have to be a bit careful is if I tell you what is tangent inverse of infinity. Remember, the only one that gives you infinity was pi over 2. And be careful when the number is negative. So for example, you have tangent inverse of -1. Remember that this is negative, and according to this part, if this is negative, it has to be on the 4 quadrant, so it has to be here. So the reference angle is 45 degrees, or pi over 4. So therefore this will be either minus pi over 4 or minus 45 degrees. If you want to write it positive, it will be 315 degrees or 7 pi over 4. Either way is correct. Okay. Now the last thing is the most complicated for some people, because now you can combine sine and cosine into a single equation, and you may have to use more stuff than just the special triangles, but we have also done that before. So let's go to that part. Here is a classic example. Let's say you have the following problem. So these are examples that are more complicated. These are examples that are going to be used a lot in Calculus 2. You have to take Calculus 2. So let's say you have the following problem. They ask you to simplify tangent of sine inverse of 3 over 4. Notice that this part essentially is just the angle theta. Okay? So therefore, you should do this on the side, and you say, well, if theta is equals to sine inverse of 3 over 4, that means the sine of theta has to be 3 over 4. And then just do a triangle where this will be theta, this is 3, this is 4, and then using the Pythagorean theorem, this will be 16 minus 9, which is 7. So this is the square root of 7. So therefore now, essentially, this is the same thing as finding what is tangent of theta. Well, all you have to do is look to the triangle. Notice you cannot answer this question without having done this first. And tangent of theta, it should be 3 over radical 7. And there is no need to simplify. That's it. Okay, let's try one more. Let's say now you want to find tangent. There's nothing special about tangent. You can flip this around. Let's say tangent of now cosine inverse, and let's say this is 12 over 13. Okay, again, this has to be the angle, which we'll call it theta. So therefore, just create a triangle from here. So before you do the triangle, that means that cosine inverse of 12 over 13 has to equals to some angle. So that means cosine of theta has to be 12 over 13. And then create a triangle. Keeping in mind this is theta. Notice that cosine is the opposite over the hypotenuse. So therefore, this will be phi. You should check that using the Pythagorean theorem. So essentially, this will be just tangent of theta, but using the triangle, tangent will be phi over 12. So the answer will be phi over 12. Okay, so now let me use the same triangle. And if I would, let's say I change the question to this using the same triangle. And the question was to find sine of cosine inverse of 12 over 13. Notice that this part is the same, so you still want to end there with the same triangle. You still want to have this. The only difference is that now I'm asking you for sine. So therefore, sine, remember, is the opposite over the hypotenuse. So this will be phi over 13. And that's it. Let me make an important note here. For this particular problems, so this is a special case, and this is a property of inverse functions. If you do a sine inverse of sine, or whatever angle it is, the answer is always going to be x, so you don't even have to do anything. But that assumes that these two are exactly the same, which you notice that's not the case for the problems we did. So this is very useful, you notice that, but the question has to be exactly the same. So for example, if I ask you how much is sine inverse of sine of 40 degrees, this will be 40 degrees. That's it. If I ask you what is tangent inverse of tangent of pi over 4, this will be just pi over 4. But if these two are not the same, this is not true, and also you have to make sure that this value is in the correct quadrant in order to be an inverse function. Okay. So now, if that's not the case, then you have to do the problems this way. So let's do another problem. This one is one of the classic problems that you will see in calculus 2. Let's say they ask you to find cosine of tangent inverse of x. Okay. So it's the same trick. The only difference is that this doesn't tell you what the value is. Remember that if this would have been cosine, the answer is x, and you're done. Okay. So here, this one we're going to call it theta. So this implies that theta is equals to tangent inverse of x, which means the tangent of theta is equals to x. Okay. So then we're going to do a triangle, and if tangent is x over 1, so it has to be 1, and then you use the square root, this will be x squared plus 1, okay, because we don't know what the value of x is. So once you complete that, then from here, remember we're trying to find cosine of theta, but cosine of theta, it will be 1 over the square root of x plus 1. So this will be equals to 1 over the square root of x squared plus 1. If the question instead would have been this, let's say sine of tangent inverse of x, since this is the same thing as this is going to be the same. So essentially it's asking you what is sine of theta. Well, sine, remember, is the opposite over the hypotenuse. So it will be x over x squared plus 1. And that's it. Now, just to show you what I told you on the note that it is true, let's say that for f, you will have tangent of tangent inverse of x. I told you if these two things match, the answer should have been just x, okay? But let's check if that's the case. So therefore, this should be tangent of theta, but tangent of theta is x over 1, which you can tell that is exactly that. So if these two are the same, that would be an easy case. Otherwise, you have to do more work. And that's it.